Good morning, class. My name is T. Bamshebi Stamps. I'm the tutor for CSE 206 Human Computer Interaction. As we all know, we have done section 1, 2, 3. This is section 4, course unit 2. User interface design principle and criteria rationale. We have done interface guideline in unit. The learning outcome of this is expected that by the end of this unit, the student should be able to carry out and evaluate simple design using some primary design principle, and they should be able to experiment design using the experimental design principle, to be able to explain the 13 principle of display design, and to also learn the normal 7 design principle. Then to know the concept and type of design rationale. Introduction. User interface design principle and criteria rationale. The human-computer interface can be described as the point of communication between the human user and the computer. The flow of information between the human and the computer is defined as the loop of interaction. Design criteria and principles are important to designing a new user interface and to evaluate a current user interface. There are 7 principles that may be considered at any time during the design of a user interface, and they are tolerance, simplicity, feasibility, affordance, consistency, structure, and feedback. These are briefly discussed in this unit, meaning that if you are designing a criteria or rationale for a new interface, you must consider the first interface, and there are design interface principles that you must be put into consideration, which I just mentioned them. So it will be fully discussed in this. So the following 7 principles mentioned in the introduction above can be used to guide and evaluate design at any time in the process. The principle can be reframed or restructured to suit a particular company or project or by professional designer. Feasibility principle description, clarity, and the example is the goal obvious? Are icon used? So feedback, information, the principle of feedback is information set back to user after their action. Is the feedback in sound? Is there a label showing success or failure? Affordance. How clear is the use of the elements to the user? Label push on one side of a door or button saying click me. Simplicity. Utilize the principle of usability. Then place an open file option on a menu under file tag. Structure. Are the elements set out in a meaningful way from the perspective of the user? Grouping information within a dialogue. Then consistency. How easy it is to learn and remember the appearance, positioning, and behaviors of the elements. X. To close a window is always on top right hand side of the window. The most important buttons are the same size with only label indicating different goals. Tolerance. Prevent user making error for provide easy recovery or grateful failure. Ignoring of wrong or invalid keyboard input. Hiding options inappropriate in a context. Primary design principle. The loop of iteration, you know what we call the loop of iteration? That is the link between the human and the system. The loop of iteration has several aspects to it, including task environment, inner condition and goals set upon the user. The machine environment. This is the environment that the computer is connected. E.g., a laptop in a college student dormitory room. Areas of the interface. Now overlapping, non-overlapping area involve processes of the human and computer not pertaining to their interaction, while the overlapping area only concern themselves with the processes pertaining to the area of interaction. Then input flow. This begins in the task environment as the user has some tasks that require using their own computer. Outputs. This is the flow of the information that originates in the machine environment. The feedback. These are loop through the interface that evaluate, moderate, and confirm processes as they pass from the human through the interface to the computer and back. Experimental design principle. Experimental design principles are also important to evaluate a current user interface or to design a new user interface, and they are described below. Experimental design principle 1. Early focus on users or tasks. Establish how many users are needed to perform the task and determine who the appropriate users should be. Someone that has never used the interface and will not be the interface in the future is most likely not a valid user. In addition, define the task the users will be performing and how often the task needs to be performed. Meaning that you can't design a system for those who are not in need of it or who will never use the system. And you can't put a task that might not be needed at the end of the day. So you have to know the user that is going to use the system and at the same time the tasks that they are going to use. Empirical measurement. Test the interface early on with real users who come in contact with the interface on an everyday basis, respectively. Keep in mind that the result may be altered if the performance level of the users is not an accurate depiction of the real human-computer interaction. Establish quantitative usability specifics such as the number of users performing the task, the time to complete the task, and the number of errors made during the task. Interactive design. After determining the user's task and empirical measurements to include performing the following interactive design steps. Design the user's interface. Test the interface design. Analyze the results of using the interface. Then repeat the interactive design process until a sensible, user-friendly interface is created. Like what we said, that design, prototype, evaluate, redesign, then prototype again, then evaluate again until desired process, until sensible or user-friendly interface is created. That's what they are simply saying here. So design methodology. A number of diverse methodology outlining techniques for human-computer interaction design has emerged since the rise of the field in 1980s. Most design methodologies stem from models for how users, designers, and technical systems interact. Early methodology, for example, treated users' cognitive process as predictable and quantifiable and encouraged design practitioners to look to cognitive science results in areas such as memory and attention when designing users' interface. Modern models tend to focus on a constant feedback and conversation between users, designers, and engineers and push for technical systems to be wrapped around the types of experience users want to have rather than wrapping user experience around a completed system. User-centered design. User-centered design is a modern, widely practiced design philosophy rooted in the idea that users must take center stage in the design of any computer system. Users, designers, and technical practitioners work together to articulate the wants, needs, and limitations of the users and create a system that addresses these elements. Often user-centered design projects are informed by ethnographic studies of environments in which users will be interacting with the system. Display design. Display are human-made artifacts designed to support the perception of relevant system variables and to facilitate further processing of that information. Before a display is designed, the tasks that the display is intended to support must be defined, e.g., navigating, controlling decision making, learning, entertaining, etc. A user or operator must be able to process whatever information that a system generates and display. Therefore, the information must be displayed according to principle in a manner that will support perception, situation awareness, and understanding. This, the 13 principle of display design. These are principles of human perception and information processing that can be utilized to create an effective display design. A reduction in errors, a reduction in requirement training time, an increase in efficiency, and increase in user satisfaction is a few of many potential benefits that can be achieved through utilization of this principle. Certain principles may not be applicable to different display or situation. Some principles may seem to be conflicting, and there is no simple solution to say that one principle is more important than another. The principle may be tailored to a specific design or situation. Striking a functional balance among the principles is critical for an effective design. 1. The principle 1. Make display legible or audible. A display legibility is critical and necessary for designing a usable display. If the character or object being displayed cannot be discernible, then the operator cannot effectively make use of them. Avoid absolute judgment limits. Do not ask users to determine the level of a variable on the basis of simple sensory variable, e.g., color, size, loudness. This sensory variable can contain many possible levels. 3. Top-down processing. Signals are likely perceived and interpreted in accordance with what is expected based on a user's past experience. If a signal is presented contrary to the user's expectation, more physical evidence of that signal may need to be presented to assure that it is understood correctly. 4. Redundancy gain. If a signal is presented more than once, it is more likely that it will be understood correctly. This can be done by presenting the signal in alternative physical form, e.g., color and shape, voice and print, etc., as redundancy does not imply repetition. A traffic light is a good example of redundancy, as color and position are redundant. 5. Similarity causes confusion. Use discriminable elements. Signals that appear to be similar will likely be confused. The ratio of similar features to different features causes signals to be similar. For example, A42 3B9 is more similar to A42 3B8 than 92 is to 93. Unnecessary similar features should be removed and the similar feature should be what? Highlighted. Mental mode principle. So under mental mode principle, principle of pictorial realism, a display should look like variable that is represent, e.g., high temperature on a thermometer show a higher vertical level. If there are multiple elements, they can be configured in a manner that look like it will be in the represented environment. 7. Principle of moving parts. Moving elements should move in a pattern and direction compatible with the user's mental mode of how it actually moves in the system. For example, the move element on an altimeter should move upward with increased altitude. 8. Minimizing information access cost. This is one of the principles of based on attention. When the user's attention is diverted from one location to another to access necessary information, there's an association cost in time or effort. A display design should minimize this cost by allowing for frequently accessed sources to be located at the nearest possible position. However, adequate legibility should not be sacrificed to reduce this cost. Proximity compatibility principle. Divided attention between two information sources may be necessary for the completion of one task. These sources must be mentally integrated and are defined to have close mental proximity. Information access cost should be low, which can be achieved in many ways, e.g., close proximity linkage by common color, pattern, shape, etc. However, close displaced proximity can be harmful by causing too much cluster. Principle 10, principle of multiple resources. A user can more easily process information across different resources. For example, visual and auditory information can be presented simultaneously rather than presenting all visual or all auditory information. Memory principle. That is the principle 11. Replace memory with visual information. Knowledge in the world. A user should not need to retain information solely in working memory or to retrieve it from long-time memory. A menu, checklist, or another display can aid the user by easing the use of their memory. However, the use of memory may sometimes benefit the user rather than the need for reference to some type of knowledge in the world. E.g., expert computer operators would rather use direct command from their memory rather than referring to a manual. The use of knowledge in a user head and knowledge in the world must be balanced for an effective design. Principle of predictive aid. This is 12. Proactive actions are usually more effective than reactive actions. A display should attempt to eliminate resource demanding cognitive tasks and replace them with simpler perceptual tasks to reduce the use of the user mental resources. This will allow the user to not only focus on current conditions but also think about possible future conditions. An example of a predictive aid is a road sign displaying the distance from a certain destination. Principle 13. Principle of consistency. Old habits from other display will easily transfer to support processing of new display if they are designed in a consistent manner. A user long-time memory will trigger action that are expected to be appropriate. A design must accept this fact and utilize consistency among different displays. The normal 7 design principle. Use both knowledge in the word and knowledge in the head. In normal 7 design principle, use both knowledge in the word and knowledge in the head. Simplify the structure of tasks. Make things visible. Then break the gulf of execution and evaluation. Then get the mapping right. 5. Exploit the power of constraints, both natural and artificial. 6. Design for error. Then 7. When all else fails, standardize. So, design principle formulated in principle of learnability. Then principle of flexibility comprises dialogue initiatives. This is the freedom from system imposed constraint on input dialogue and compares the system against the user preemptiveness. Multi-threading. This is the expressing the ability of the system to support users' interaction for more than one task at a time. It also looks at the concurrent and interleaving multimodality, then task migratability. This is passing responsibility for task execution between user and system. Substitutivity. This is allowing equivalent value of input and output to be substituted for each other. It compares representation, multiplicity, and equal opportunity. Customizability. This is the modifiability and adaptability of user interface by user, or the modifiability and adaptivity of the user interface by the system. The principle of robustness are made up of observability. Observability, this is the ability of the user to evaluate the interface state of the system from the Perceivable representation. It considers the browsability, the default, the reachability, the persistence, and operation feasibility. Recoverability. This concerns the ability of the user to take corrective action once an error has been recognized. It looks at the reachability, the forward and the backward recovery, and commensurate efforts. Responsiveness. This is how the user perceives the rate of communication with the system and how stable is the response. Task conformance. This explains the degree to which system service support all the user's tasks, the task completeness and its adequacy. Design rationale. Design rationale is an information that explains why computer system is the way it is. Benefits of design rationale are communication exists through the life cycle. Reuse of design knowledge is made across products. Design rationale enforce design discipline. It presents arguments for design trade-offs. It organizes potential large design space, and it is used to capture contextual information. Type of design rationale. Process-oriented. This preserves order of deliberation and decision making. Structure-oriented. This emphasizes post-hoc structure of considered design alternatives. Two example design rationale are issue-based information system and design space analysis. Issue-based information system provide basis for much of design rationale research, and it is the issue-based information system are process-oriented. The main elemental structure with one root issue. This describes the hierarchy to positions. This contains the potential resolution of an issue. Arguments. This modifies the relationship between the position and issues. The graphical version or structure of IBIS is produced below. Issue, sub-issues, specializes. Then response, questions, sub-issues. So these are simple graphical representation of design issue. Design space analysis. This is structure-oriented questions, option, and criterion. It's a hierarchical structure made up of questions and sub-questions and represent major issue of a decision to the questions, while the criteria are the means to access the option, provide alternative solution options in order to make a choice. The questions, option, and criterion notation. Question, option, and criterion notation. Characteristic of psychological design rationale. To support task artifact cycle in which user tasks are affected by the system they use. It aims to make explicit consequence of design for users. Various scenarios are suggested to text task. Users are observed while using the system. The psychological claims of the system are made explicit. The negative aspect of the design can be used to improve next iteration of the design. The conclusion. The various design principles mentioned can be used to guide or evaluate design at any time in the process. The principle can be reframed or restructured to suit a particular company or project or by professional designers. In summary, experimental design principles are important to evaluate a current user interface or to design a new user interface. They comprise the empirical measurements, and intuitive design. Most design methodologies stem from a model on how users, designers, and technical systems interact. User-centered design is a modern, widely practiced design philosophy rooted in the idea that user must take center stage in the design of any computer system. Display are human-made artifacts designed to support perception of relevant system variables and to facilitate further processing of that information. Principle of display design comprises the perceptual principle, the mental mode. Based on an attention and the memory principle, design rationale is an information that is why computer system is the way it is. It could be process oriented and or structure oriented. Thanks for listening. We have come to the end of this section or this section for unit 2. So we will meet in the third